the daily arithmetic challenge. On the screen are your first 6 questions for you to have a go at today. Now we're actually at the end of the test paper that we have been looking at, so on the next slide, rather than being more arithmetic questions, there are actually a couple of quite tricky reasoning ones for you to have a go at, but don't worry, we will also go through those answers at the end. So pause your screen now, have a go, and when you're ready to go through the answers, press play. To go through the answers then. Question number 1, we've got 1 quarter divided by 2. So straight away it's a dividing fractions question, so I would use the KFC method. The first thing that you can see that I've done is I've actually turned the 2 wholes into a fraction. It is 2 over 1 because you've got 2 whole lots of 1. Now that they're both a fraction, that makes dealing with KFC a lot easier. So K stands for keep the first fraction the same, so 1 quarter stays the same and I've written below. Flip the operation symbol, so I'm flipping it from a division to a multiplication, and change the last fraction, which means that you swap the numbers round, so you have then got 1 on top and 2 on the bottom. And then you multiply them together, so you've got 1 times 1, which is 1, and 2 times 4, which is 8, so your answer is 1/8. Number 32 is a order of operations question. So I've written the question out again, and using BODMAS or BIDMAS, the first thing that you get to that you have to deal with is your orders or indices, so your squared or cubed numbers. Now as you can see, I've got 9 squared on there. 9 squared, it means 9 nines, so 9 nines are 81, not 9 times 2. I then write out 36 divided by 9 the same, because we've not dealt with that yet. I then look at the 2 methods I've got left. I have a subtraction and I have a division. I know that division is the next thing that I have a go at in terms of BODMAS or BIDMAS. So 36 divided by 9, 4 nines are 36, so I've written 4 underneath, and then all I do is carry my 81 down, and 81 subtract 4 is 77. Number 33, we've got 1 and 1/2 multiplied by 40. So again for this one I've actually turned 40 into a fraction. So I have done 40 over 1 because it's 40 whole lots of 1, and then then I've turned my 1 and 1/2 into an improper fraction. So I've got 1 whole lot of 2 and 1 left over, which is 3. So I've got 3 over 2 multiplied by 40 over 1. When you multiply them together, you multiply both the numerators and then both the denominators. 3 lots of 40 are 120, and 2 lots of 1 is 2. And then what I can do is I can turn that into a whole number, because I know 120 can be divided by 2. Basically, it's asking you to half your number, so half of 120 is 60. Number 34, 28% of 650. So the first thing I did was write out the easy fact. So 100% is 650, 10% is 65, 1% is 6.5. As you can see, I've divided by 10 every time. I then times 10% by 2, because I need to find 20, 2 lots of 10, so that's 130. And then I times 6.5, which is 1%, 8 times, because I want to find 28%, which is 52.0. And then I add those two together. Now as you can see, I've got rid of the 0.0 because I don't need it anymore. There's no value after that place decimal point. So it's 130 add 52, which is 182. 35, we've got 4 2/3 subtract 1 6/7. So there's 2 issues here. We've got mixed fractions and we've got different denominators. So the first thing I did was turn them into improper fractions, get rid of the whole numbers. So I have 4 whole lots of 3 and 2 left over, which is 14 over 3. And then I have 1 whole lot of 7 and 6 left over, which is 13 over 7. But this still doesn't help me because my fractions are over 2 different denominators. Now if I multiply my 2 denominators together, I get 21, which is a common multiple of the 2. So then I multiply my numerators by the same thing that I've multiplied my denominators by, to give me 98 over 21 and 39 over 21, and then you do the subtraction like normal, subtract your 2 numerators and you don't touch your denominators, it stays as 21. 36, so the last question in this paper, which is worth 2 marks, is 8,827 divided by 97. Now again, with the other very similar question that we looked at the other day, Write out your multiples of 97. Add them on every single time. If you need to use a method, use a method. Just make sure that you don't make any silly mistakes, because if you make a mistake writing your multiples out, the question will be wrong. So I then did 97 into 8, which is my first number. Well, I can't do that. If I've got 8 marbles, I can't share them out between 97 people. So I move my 8 across and I place a 0 on top. I've now got how many 97s can I get out of 88? Again, I can't. 88 is a smaller number than 97. So this time I cross them out and I carry both 8s across. So now I need to find out how many 97s go into 882. Now, as you can see, I've written all of them out down the side, and I can see it goes in 9 times, but not 9 times exactly, because 9 times 97 is 873. And you can see that what you've got up on the top is 882. So what I've done is 882 take away 873 and got the answer 9. I then carry that 9 over into the next place value, which gives me 97, and I can see that obviously 97 goes into 97 one time. Equivalent means the same. So it's asking you to circle the improper fraction that is equivalent to 6 7/8. So for this one, I had to find out what that would be as an improper fraction. So if I've got 6 whole lots of 8 and 7 left over already on my numerator, that gives me 55 over 8. And as you can see, that is the improper fraction that's given for you in the list. Number 14, write these fractions in order starting with the smallest. Now, there are 2 ways that you could have done this. You might have been able to spot straight away the order, because 6/5 is clearly going to be the largest fraction, because it's the only fraction that is top heavy. So where your numerator is bigger than your denominator, which means that you've got a whole and then some left over. If we then got rid of that one and placed that in the largest box, we then have to deal between 3/5 and 3/4. So the way I always visualise this, if I had a pizza cut into 5 pieces and I was offered 3 slices of it, or I had a pizza cut into 4 slices and were offered 3 of it, which would you get the larger piece for? Well, you would clearly get a larger piece if you got the 3/4 of the pizza, because you are having 3 out of 4 slices rather than 3 out of 5 slices. So that would make 3/5 the smallest, 3/4 in the middle, and 6/5. Alternatively, you could have turned them all over a common multiple, a common denominator, which at the side I have found 20. So you would have had to have multiplied your numerator. The only risk with that is that when you come to write your answer again, you have to remember to write the original 3 fractions, not the fractions that you've changed them into. And 23. 24 hours. The length of a day on Mercury is 58 2/3 times the length of a day on Earth. What is the length of a day on Mercury in hours? So what it's basically asking you to do is 58 2/3 multiplied by 24, which I've written out on the side. So I've separated this out and I've dealt with my whole number first. So I've done 58 multiplied by 24, which is 1,392. So they're the hours that we know of already. I then need to do 2/3 multiplied by 24. As you can see, I've put 24 over 1 to turn it into a fraction, because it's 24 whole lots of 1. I then multiply them together like normal. So 2 lots of 24 is 48, and 1 times 3 is 3. I can then divide 48 by 3, which is 16. So I've got 16 whole hours there, and then add together the 2 lots of hours that I know to give me 1,408 hours.